Hello. In this lecture, we will make a practice on what we learned so far. Uh, in fact, we have almost an end of our curriculum for this lecture, and also we have finished theoretical background in this lecture, and later we will focus on the practicing what we learned so far, and also using our information, using our theoretical background in the real life example. The most important thing for these applications is we will deal with some kind of data pre-processing approach, because the textbook examples and the real life examples are not same. In textbooks, everything is clear, and every data are accessible and without problem. Even you cannot experience problems like encoding or language problems or something like that. But in real life, when you apply, when you try to collect data from various sources, you will experience the problems of the encoding, we are saying, for language. Even, for example, if your data includes a punctuation or even emojis or non-alphanumerical values, you will experience the problems when you run your codes. The second thing is we will see that the gathering data is not something easy, because we are somehow used to get data from the open source like GitHub or Kaggle or various open data sources. But if you want to learn, if you used to learn data science in real applications, sometimes you need to collect your data in your own way, not from the open sources. It is, as a researcher, it's your task. So we will apply into this lecture. We will apply an application from zero to hero. What it means, we will get our data from open web, but we will scrap it, not getting directly or downloading data directly, and we will process together, because it's the part of your task to understand, to process data in real life application. Then we will use what we learned so far as degree centralities and other things. And also we will try another approach for a Louvain cluster centrality approach to detect community in our data. Don't forget that, keep in mind that today the scraping part and the processing data part is not your responsibility, because it's a bit tricky. But what I expect from you is just focusing the network parts and using the theoretical parts in your application. But as I said, friendly advice, focusing the pre-processing part may help to you in your research project, because a lot of people, after the passing boot camps or lectures about the data science, focus to at first they start and they getting the cool shower, because the real life examples in data science is not same as in the textbooks. That's why I'm just a friendly advice. I'm saying focus to the data processing part. What is our topic today? Today, as I said, you remember, when you want to make a network analysis, you might think I cannot have any data, but if you focus proper into life, especially in the internet or web, you can find a lot of interesting and good source for data. what is the matter of focus is just seeing the connection between the selected or limited list of the things or entities, persons, telephone numbers, books, products, whatever you think. But if there's a connection between the things, okay, you can gather network data from that. So in today's example, we focus on Amazon website to find interesting thing. As you see in my screen, there is a book, Nudge, Improving Decisions About How to Attain with Happiness. That is a kind of self-help book and very popular nowadays. In fact, it's in my book list. I'm in my reading list. But before starting to reading the book, you may ask, who reads this book, and is there any connection between this book and the other books within the scope of the people? For example, when you look at this website, don't think about foreign network for now. You as you see, we have customers who bought this item also bought. What it means that there are some persons we don't know about. They are bought or weaved this yellow book, and they looked again these books. Is there any connection? Is there any meaningful relation between these things? And the most important part is there any relation about the topics? Think about, for example, we looking for a financial book. Is there other books in the bottom, as you see, are related by their topics or by their context? So how this approach will help us? It's easy if we find some books within the scope of every book. We can say, okay, the book I found in within the intersection of these relations, okay, these books may be good books or popular books or good books for reading. So without making a network analysis, we cannot understand that. So, okay, the $1 million question is, how can find these connections? Before these connections, how can gather this connection data of this connection? At first, you might ask, okay, I can open a notebook or a piece of paper, and I can try to write in the first column nudge, the second column is the misbehaving, and again the first column is nudge, and the second column is thinking fast and slow, the Kahneman family books, and we can gather our own data manually. It's possible. There's not something wrong, but it's a very tedious task, and nobody wants. I don't think nobody wants to make this kind of data gathering. But we have some options to gather data, except that what we are saying, it is data scraping, and by the data scraping, you can scrape any kind of data that you see in the websites. Let's say if you can take a note about your data, that I explained so far, you can scrap, you can do it, you can perform it not manually, you can perform it by writing code or using the special softwares to gather this kind of data without overwhelming task. And even if you do that, you can gather even millions of data from any websites. But keep in mind that it's not free. Sometimes some kind of websites doesn't allow you to perform or run this kind of codes, because some web applications thinks that you are some kind of hacker or some kind of malware that try to get raw data from their websites. And a second important thing is, when you make a scrapping in any website, it will affect the power of or performance of the websites. That's why somewhat legally some websites explains and says, never scrap my websites. But for learning task like we will see today, and for small scope scrapping task is not problematic, and you can gather data. So how can you gather data? There's tons of applications like Scrappy with the Python, and Selenium library with the R and Python and Java library. You can scrape data. In fact, all test libraries for software development, it's also useful for scraping data. Okay, I'm not focusing and go deeper in the scraping data, but just a glance. Let's see how it works. Okay, if you need to install Web Scrapper IO library and to your Chrome extension, you can install this library from the Chrome store. And after your installation, when you right click and open the web developer toolbar, there is a tab that Web Scrapper we are saying. So you can generate a new sitemap, and you can copy the address of the websites that you want to scrape. And again, you can select whatever you want in the website. Let me show that. For example, for Amazon, it's not here. Sorry, let me show from first, because I scrapped my data from another computer. Okay, let's generate a sitemap, and I'm copying the URL, and as you see, let's say name Amazon, and I generated sitemap. What is a sitemap? A sitemap refers, I will scrape data from just within this website. I can make more. I can define more complicated URL pattern to scrape not only one website. I can scrape more than one. So, but for scraping the things in websites, you need to use information for the web development experience or HTML or CSS. That's why it's a bit tricky. Let me show. Let's say you want to scrape here within the website, it's easy. You should generate a selector. I'm generating a selector for text. You can get image, pop-up, link, or other things. For this task, I'm generating more complicated scrapping selector to get the button, books in button. So let me show. When I selected text, and I'm selecting the here, as you see here, CSS selector, product title, I'm saying don't select, but don't think something easy, because sometimes complicated and nested structure of the websites doesn't allow you to select so easy. But for this example, it's quite easy, don't worry. Okay, I'm writing ID for my selector. I'm writing title. So when I run data preview, as you see, I'm seeing the things. And as a second selector, I'm saving, and again I'm opening another selector. I want to get all books in the bottom. Let's say. So I'm click again. Let's say I just want I don't want to get their links. I just want to get their title. Of course, I can get their ratings, and again, in fact, I get. So I'm selecting the here, and I'm writing, as you see, but here I click in complicated CSS codes, but I don't want to get. So, but I can write again my code with div division, and I'm trying to, yes, okay, I got the things by the clicking preview. And my code access only the books that I want. So when I click the data preview, I should get the list of books. Okay, I'm getting that. So by the way, when you save the selectors and start to scrape data by the clicking here, it starts to go to websites. How many websites that is important, and finished its task. And when you refresh your data, you are getting the names and other things in the websites, including the, let's say, if you selected, including the name of the authors, name of the books, name of the even price of the books. And by the scraping data, you can get whichever thing in the websites. Okay, that's the part of scraping. So if you want to access, you can write from extension and web scrapper.io. So here the address of the URL, and you should install this scrapping tool into your websites. It's not only a thing, and if you want to run a code, you can run R and Selenium, or even on Harvest. It's interesting library. It's easier than other libraries. Let me show just one example. So, sorry, I may don't remember the name of Harvest. Yes, not Harvest. Okay, here the Harvest package, and you can scrape data with by the coding, but every time in which Harvest and with even with the web scrapper.io Chrome extension, you need to have a background information background information about the HTML, because everything in the websites are coded by the HTML. That's why you, and CSS, of course, you need to understand which part is the important and which HTML and CSS code is best for your selection. And you can run, for example, in these websites, you are opening the websites and writing a code to read HTML, and before that you have a HTML document tags, but everything is messy. You cannot access anything here. But if you, for example, you write the code, access the HTML nodes with P. What is the P? P is just paragraph in the HTML websites, and when you run this code, and you will get the only text from your content. Okay, so let's focus on what we did with data. I scraped the data with Amazon from the Amazon websites. Let's have a look in the data, and as you see, we have 3 columns: the title, the name of book, and the weaved or bought title. Of course, here this rows or titles, but what title of the related books? For what we understand that, for example, most of users that have or looked the misbehaving book in the 3rd column, they are focused or bought in the winner course books again. So when you look the codes, as you see, we have get our data. We have used the deployer package to filter or sort our data or manipulate our data more easily. And we have just selected these columns. Why? ISBN column and rating column, because we will use these numbers for our analysis. But for now, we have focusing the 2 column. Again, we have filtered the title that have not any text inside. It's the part of pre-processing. When you run code and you see when you see that some rows have not any text, and if they are null, you can write this kind of filtering columns to get only the filled or full columns or rows. And again, I'm deleting or filtering the 4nd column to be able to get rid of the null columns. So for this, not for every scraping, when I look for this data, I see that there's some HTML tags within my data, and it's not meaningful. That's why I wanted to delete them with the writing grapple function. As you see, grapple function is for seeking data, seeking string pattern within the string pattern When you write this code, you will get only the exact matching. But if you use grapple, what it means, what if, for example, if you write this A, B, C, D, and if you write a grapple function with AB, it will get here and again get here ABX, AB something other. But for this example, we have just some strings that include image alt tags, and we want to get rid of them. That's why we have written this function. Okay, we have clear and cut two-column data for network analysis. What we will see at first, what was our first task? We should we should visualize our data to see what happens. Okay, but before doing that, due to the complexity of data, I called my iGraph library and I converted my graph, my data frame to graph, and I get the degrees. Why I used to try and catch? Because my data is not flawless and it includes some non-numerical values. That's why I used to try and catch. If you don't use try and catch, you will get some degrees that not 0 or 1 or numerical value. That's why in your analysis, you will experience some problems, some trouble, and that's why I have used try and catch, because before the using try and catch, my code didn't work and I didn't get anything. So of course, again, I'm getting the vertex log for what? Because I have so many titles, and I just, for this example, I can change, but for this example, I am just want to get the label of or name of books that their degree centrality values is bigger than 10. For bigger networks, it's a quite good strategy, because you may don't want to deal with the unimportant data. For example, here there's some books, they have so many connections, more than 10. It's important than the other books that have a few connections. That's why I generated this kind of text. But of course, you can you don't need to, it's not not compulsory to do that. But if you don't filter your graph data for this kind of examples, what you see is completely messy and overlapping labels in your network, and you will not understand anything. So let's plot our data. Okay, you are seeing data clearly because I filtered the labels. As you see, for example, let me make bigger. As you see in here, here in the end, and the points in the ends, as you see, they have not any label. In fact, they have labels, but I filtered. Why? Because I don't want to see the points that has their connection has more than 10, less than 10. That's why you are seeing the connection or points more than 10, and we have slightly clear network. But we have, it's not only option, we can change, we can modify our network to understand more than that. What we did here is, again, remember, I set the size of the points by the degree centrality, and that's why some points has some points very small and others are big, and we are seeing better. And I'll set the font value of the labels with the 0.7, and if I increase this number, the font volume of the text will be bigger. And again, I'm decreasing the size of the arrows because I don't want to see the bigger arrow and overlapping arrow. It's just a rule of thumb. There is no clear numbers, and when you make your visualization task, you should make a change by the rule of thumbs, by trying and catching, and up to arriving good visualizations. And I used the layout fractal marine gold. Why? Because I did so many layouts, and I got the best picture with the layout fractal marine gold. Okay. So, but sometimes your customer or your master researcher will ask you, so, dear Ibrahim, dear Serkan, I want to see everything within the network, or I want to make a big picture of the network. This kind of situations, in fact, you cannot visualize data within your RStudio. In that sense, you need to rescale the picture and export and see your picture out of the RStudio. For this example, I changed the layout, and this code is just for rescaling your how can I say, canvas. When you scale your canvas to see everything in the big canvas, kind of big poster. So again, I'm setting rest factor. It's just a rescaling. If I increase this number, I will get bigger picture, but we don't need that because sometimes the size of the picture becomes very big, huge, and that doesn't help to. It is not good when you send your data, your picture with email or with other transfer options. So here I set my file name with Amazon PNG, and I set, look here, my height and width very big as your laptop screen. But if you don't set these numbers, the picture you will get will be very small. Okay, and I'm using the PNG function to export the last plot function. When you write the plot function here, it says to RStudio, focus the next plot function and get the plot into this file. When you do that, you will get your results within the file, and you should write the dev function to stop this. And within the plot function, I changed some parameters to get the picture better, and I set a layout to make our picture bigger. Okay, when we run our code, we didn't see anything for now, but when we look for directory, we will see the big picture. Okay. At first, it's not zooming, and when you zoom in with your mouse, you can see the things better. As you see, it's kind of Google Map or Google Earth, and you can take a journey within the books. What it means, let's focus on one. For example, here, workbook, it's a book, Atomic Habits, and a lot of people have checked in websites this book, and other books. As you see, the important thing is it's a community, okay, but as you see, there's some book, for example, here, it is within the intersection of the different community. What it means, because maybe it's due to the popularity of book or the topic of the book. The second important thing is when you scrutinize the data or books here, you will see that some community is just about the finance, but some community just about the self-help or the personal growth. But there is also some books is shared between the communities, and there's some communities that hybridly includes so many different topics. But at the first thing that we get first insight we get from this data is uh, uh, although we have a list of books within our books in the Amazon, in fact, they are looping within our community. But in fact, there's so many books everybody now and everybody check. That's why we understand that the world of the books, for this example, it's not so big. And if we focus the good books within the intersection of the networks, we can tune in into the trends of the books. Okay, it is just an example of network science in our tasks. Okay, let's continue. We have so many options. Let me show another option. We have a simplify function in the R. It is specially for simplifying bigger networks. Just to understand, you may ask why I am simplifying a network, because we are simplifying networks to understand, to get picture from think about kind of aircraft, and within aircraft, when you take a picture of Earth, of course you cannot see the bees or flies or even animals, but you can understand the big picture. You can see the big picture, and again, if you want, you can focus special part of this network. The simplify function is just for helps this task. Okay, let's run again. It's everything is same as we did so far, and we didn't use G or graph directly. We just used the simplify function and to see simplified version of our network. And again, here we have another parameter. What it means for simplifying our network? We are saying to our if any point if any point page rank value is bigger than this value, just show. But if it's smaller than this value, hide this kind of notes to make our graph more understandable. Okay, as you see, in fact, we changed the clearness of some points to understand, because if as you see, we just seeing the important part of this network by the simplify function and by the display isolates parameter. Sorry, by the of course, by the setting or label according to the page rank. What was the page rank? Remember the degree centrality and edge between this centrality. Page rank is also kind of degree centrality's value, and it is when you run the page rank, you will get almost same results with the degree centrality and other centrality values, but the algorithm behind the PageRank algorithm is not easy to understand, explain. But for now, we have used it just for simplifying our network, and we said if it is smaller than the small value, just set or label an A. That's why we are not seeing the values within the endpoints. So here we have used our first initial vertex library and degree centrality values, and again we are getting another different picture. In fact, the strategy we have did in this example is same as with the previous ones, but I just want to say that what you can change the values and parameters to get different pictures. And second thing is, let's focus here set seed function. Maybe you know, if you don't use this function, whenever you run your code, you will get different picture. For example, run again. Let's run again. You get different or slightly different picture. But if you use set seed function and set seed left right again, and define a random number. Let's try. Okay, if you satisfied with this picture, how many times you run, you will get the same things here. Why? Because we set our function and we kind of fixed, or we make freeze our picture. If you change the number with the random, no matter which number, you can write 1,000 or 100, it will be changed. So up to arriving the good picture, change the number, and when you get, don't change the number for getting the same result when you run the function, because this function, the function you have used in your visualization, includes some randomness. That's why whenever you run, the function will give you different results. The set seed function is dedicated for this task. Okay, so let's think about a scenario that your customer or your professor wants to see every note, and he or she wants to touch every note and check the neighborhoods in your network like Gaphy. For this task, you may remember we have learned with network package and what with network package task. It is generates a visual, zoomable, clickable graphic within the RStudio, and you can play with your network. So let me run. The best part of this network package is when you run this network, you can import your data from your iGraph package. In fact, iGraph and the Wiz network package are different. When you run, when you have an iGraph object like G, you can use within your Wiz network package. And what you should do is you are writing G within your with iGraph, and we will get this network. But I have used some different parameters. For example, physics parameters helps to if you set it true, your network will be kind of you will be trembling up to getting the statical or stable position. It works dynamically, and if you set navigation buttons, you will see the navigation buttons like here to zoom in and zoom out your network. And again, we have some options. We just want to see we can access by this with graph the list of books in network, and when you click and select any item in this list, you will access directly this point and this neighborhood. Okay, let me make show. As you see, it is zoomable, and you can zoom any place, and you can set again, return back, and it's kind of Google Map again, but it is not a picture. It's dynamic HTML we have. You can, as you see, we set our picture big, but the picture was static, and the picture like the picture was like a picture poster, but for this example, it is HTML reporting widget. And also the other important thing, you can change, as you see, the position to see better. The third important thing is when you write, when you select a name of book here, for example, as we see, you can access it, and you can access it with its neighborhood. As you see, it's quite good thing for checking the books and other books. As you see, the system has fade out the color of the others, irrelevant notes, and as you see, the just the point that you have focused. Okay. Again, we access the things here, and we can change the position by the navigation buttons. I think it's a very good thing. So let's return back. So what is the advantage of visual network? It's zoomable, clickable, and as you saw, neighborhood highlighting is good things to seeing the relation between the echo networks, and also of course you can change the node positions to see better. And the most important thing is when you generate this kind of graph, you can embed it your web application. As you remember, I have a web application for showing reporting the trading relation in the Ankara. It will generate the same results for you, and you can report your analysis or your research within a website. The disadvantage is reporting over a network. As you see, it's not good for print. When you print this, nobody will understand because you cannot see the names without zoom, and with network is not good for printing. But there's a solution. If you want to use, you can zoom in and zoom out the different part. For example, you zoom out here, you can print here with a snapshot, and you can change, you can access different parts of network and get different snapshot to make your report within a distributed way. So we have learned the degree centrality in our previous lessons, and okay, we know degree centrality is the number of connection, count of connection of given point in the network. Okay, for this example, what is the meaning of the degree centrality? So a lot of things. In fact, there are some books living in the intersection of the different community, and we have understand the community reflects the user's preference. We have understand this preference reflects the user's choice, user's understand perception of the popularity of the books, and so from this dedication, from this logical perspective, we can say the users, if any point have bigger degree centrality, it means it is selected by different type of users. Or if any book has smaller value of the degree centrality, we have understand it is special book and just focus, or it's the kind of book specially written in a special topics like finance or biology, let's say. When let's run our veteran code that we have learned so far. We get degree centrality, change the data frame, and we are arranging the degree centralities to see the biggest degree centralities. And as you see, the first book is the book that we have initially started. It's not important because it was the initial book for scrapping task. But as you see, the second book is about the finance. The third book is about the psychology and economy. I read this book and I advise you strongly. So we have understand that these books all about it's not the special books. They are popular books, and it is written with a good way to explain things to different people have different culture or intellectual background. It's just an explanation, it's hypothesis. It should be maybe proof, but we can, at the first, initially, we can say, we can interpret these results within this framework. Okay, so remember, we have cliques. What was the cliques? Remember the definition. A clique is a subgroup that fully connected in the bigger network. So remember, we have, for example, we have a network of Russian and Turkish people, and it was a totally artificial network. But when we run cliques function, we saw some subgroups. But what was the disadvantage of cliques? A clique requires fully connection. If any subgroup have a lot of connection, dense connection between among each other, just a single missing connection makes these cliques non-clique. But for this example, we have some cliques. As you see, when we run the cliques, the minimum number of connections is 4. Minimum number of member is 4. We have some different topics groups. As you see, it's the first cliques. It is the second. Why we are saying the cliques? Because every people, for example, looks this book, also checked the other book in the list at least once. And for example, again, for a random walk down Wall Street book, for example, Sarkan checked this book. He have checked the second book again. So what it means, why we are listing our cliques? As you see in this example, the topics of cliques is very close. For example, the second book, second clique, all about the finance. It is the good example for power of the network analysis because we have not any information about these books, but by the network analysis we have list of the different subgroups and topics, and as we see, they are all about the finance, and other books not about the finance. For example, here, these books not about the finance, they are self-help books. Okay, today we will learn the new different algorithm. So Louvain algorithm is for community detection. This algorithm, special algorithm for getting community. But when we say community, it have different explanation. For cliques, if we say cliques or that I want to detect the cliques within a network, of course we will get sub-communities, but this communities is fully connected. But if we want to, we can define different type of cliques, like different type of subgroups like K-core, you may remember, or previous lessons. The Louvain algorithm used a different way. It is a result of research, and naming is different. So how it works? If you have machine learning background, in the machine learning, algorithms. There's a supervised and unsupervised algorithm, and this kind of algorithms is based on minimizing the cost function. What is the cost function? Cost function is kind of roughly, if you minimize cost function, your algorithm will be better. That's for this aim, your algorithm or you should make a optimizing function, run an optimizing function up to get the local or global minimum point for cost function, and in that time you will access the better algorithm or better prediction tool. Let's remember for regression, what is the cost function of regression? It's the optimal square, or I don't remember the name of that for now. The cost function is a function for regression that make the distance of points to regression line the minimum. It is the cost function for regression function. So but when you use different algorithm like support vector machine, there is different cost function. So for network analysis for the Louvain algorithm community detection, the cost function is different. So in this example, the mathematical notation of the cost function is here. What it means, it is maximize the modularity of the subgraphs. And by the way, with iteration, the Louvain algorithm accessed the state that every community is really community, and their modularity is maximum. So let me show an example for Louvain example. When you run Louvain algorithm for this network, as you see, for example, that this community in the last right, it's a click, as you know, because every member are connected. But as you see here, this community, it's not a click, it's just because the point number 7 and 6 are not connected. You cannot say click for this example. But in the Louvain basic example, the algorithm access to stable status to get a optimum value of modularity within the subgroups. Of course, we cannot say they are really or totally subgroup. Maybe for example, this point may the member of another group, but as a prediction, as a near or close to near explanation for our network, we can say the Louvain example works. So well, we can, if we want to run this function for our graph, RStudio has a function cluster Louvain, and what you should do is just getting the graph function into the Louvain function. But keep in mind that the Louvain function doesn't work with directed networks. That's why you should set your directed parameter to false. And the last thing is we have set that we just want to the first and second groups. That's why we set our function by day. If you don't write this part, you will get all list of clusters. As you see, we have bigger subgroups, and in fact, it's again, it's all about not all about the finance, but we understand that this function somehow generated this network group, and we can check, we can compare the different results from different algorithms up to getting our best. So when we can visualize our Louvain clusters, as you see. we have used our simplifying function, and we cluster it. We run cluster function to get Louvain clusters, and we made it graph. As you see, these areas, this colorized areas, the subgraph that detected by the Louvain cluster algorithm. Sorry. Okay, why we are visualizing our network with different algorithm like Louvain? The important thing here is when we visualize our network, we can get some insights within our network and we can compare. As you see, the Louvain functions results are smaller and they are far away from each other. We have another clustering algorithm. In fact, we have tons of different clustering algorithms, but let's try between these clusters. It works, it's based on between these clusters. As you remember, it was a centrality measure, and we can use between the centrality to get new results, different results and clusters. As you see, we get the results like Louvain algorithm, but it's not totally same. But some clusters bigger due to the nature of the centrality. Why we did, and well, you may ask, which is the right output? The good way is comparison. I compared these two different results. The left column is the results of the Louvain cluster, and the second result is about the edge between this cluster. When I check the results, the green rows are totally different, but the yellow part is same. They are shared. And we can easily say that we can focus the yellow one because they are the shared results of the different algorithm. Of course, you can try it not only with the two algorithms, you can try and get 10 algorithm and get you the shared results. And of course, you can focus the different results, and you may ask, what is the mathematical story between these results? The last thing we will do is, so far we have used network analytics, but you may ask, is there any relation between the network analytic results and the, let's say, rating of the users? You may ask. Maybe, for example, my first hypothesis was the good books or highly rated, overrated books may have bigger degree centrality. It was my first hypothesis. Let's try and see what I did. I get the degree centrality again to CDF parameter, sorry, variable, as you see, and I will merge the data of the, let me show the ratings here, and I will make a correlation. But here, as you see, as a part of processing task, so we have numbers, but we need to get rid of this part and convert the string into the integer to be able to run the correlation function. To do that, as you see, I write a function, numerify, and when you write a rating string like this, it gets the just 3 characters of string and convert to numerical value. And as a second, we are using mutate function to convert all column for rating column into the numeric rating numeric column. When we run this code, we have rating numeric function. You may ask why we are getting this value, because I just every number, every rating was bigger than 4, and I just got the decimal part to see things better. And I'm writing here correlation function, my writing numeric, here this column, and the degree centralities. As you see, it's not good result because we understand that there is a worse correlation, but as I understand, it's quite small value, and we cannot say roughly, we cannot say there's no correlation between user ratings and degree centrality. But don't worry, these results may be false positive, false negative, because we have just 21 books. But if we increase the whiteness of our book list, and again we can try, maybe results may be different because our set is quite small, and we cannot make an interpretation with the so many small number of observation, as you see. Okay, we can so it's same thing, we can visualize, and as you see, some books is clustered in some different degree centralities, and as you understand, as we see, there is no clustering around any line. That's why we can easily say there's no relation for this example, or it's quite less possible. We can change our predictor. We don't have to use just one single predictor. And when we run the between centrality with the same thing, we get different results. It's almost same with our first predictor. And again, we can try different out degree centrality. It's same. And as we understand, okay, we have not correlation. But if you catch a correlation between your network results, network metrics, and your real data, like rating or other things like score, you can easily say, okay, I catch a good predictor for my analysis. And without network analysis, you cannot access this metric because it is the part of analysis. So let's try to see correlate. Let's check, is there any correlation between membership of the network and their ratings. As you see, we have titles and the cluster number. What was the cluster number? It's the color of the here, as you see. Let me show here, cluster 1, cluster 2, and so on. And we will check the relation between clusters and the ratings. And again, I am merging the clusters and the cluster number and the mean of the rating. I didn't, and I run the cluster number and the rating numeric. So the result is quite small, and as we understand, there is no relation with the clusters and the ratings. But we can say, as you see, all clusters somehow have same rating. There is no big cluster, but maybe we focus on here, and maybe we focus on the cluster number 8 to see good books, and maybe this club of good books or good authors. Okay, that's all. So far, we have tried to make get our data within our own way, kind of organic way, and make our analysis and getting some results. As a result, we understand what is the make our day today is a name for our next book. We can say, okay, we should the little book of common sense investing, or predictably rational book. I think I will read these books and check my analysis again. So that's all. Is there any questions? As I understand, there's no questions. Everything is clear. And I will end up today our lessons and upload our video into the Moodle. Okay, see you.
Teşekkürler hocam.
Rica ederim. Sağ olun.